So hello guys, my name is Viral and welcome to my YouTube channel. So this is a successor video of the playlist we have started for learning Go. So in the previous video, I have covered all the fundamental concepts of Go that will include that how you can write basic print statement in Go, how we can declare variables in Go, how loops are written, how what are interfaces, what are structs and all those things. So if you guys coming from this video, so that video is perfect for you. In this video, what we are going to cover is we are going to cover some basic concepts and some advanced concepts like Goroutines, channels and Waitgroups. So, and if you are not coming from that video, make sure that your Go basics are clear. If not, then you can skip that video and first go to the previous video I have made, so that you will have a better understanding of how we can write code, because in this video and mostly I'll be covering some advanced concepts. So yeah, this is the thing, and make sure guys you like and subscribe to the channel. That will be really helpful to me. So let's get straight to the video. Like, let me just tell you what we are going to cover in that video. So the first thing we are going to cover in that video is what are basically Go routines, okay, and how does Go routine works. And the second thing we are going to cover in the video is what are channels and how channels are being used to communicate between different Go routines. What are weight groups and why do we even need weight groups, and what is the difference between buffered and unbuffered channels. And the last thing we are going to we will have a practical example that will implement synchronization between two Go routines, to just to check our knowledge that yeah, whatever we are learning with a robust example, so that we can have a knowledge that yeah, all those things where we can implement all those things. So let's get started by what is basically a Go routine. So there are two things. One is Go routine and one is a thread. So Go routine are like traditional threads, but they are not exactly threads. So they are more of a lightweight threads. So unlike that traditional threads, they have power. So they are lightweight, right? So they consume less memory and they can execute quickly. So that whole idea of concurrency is based upon Go routines only. So Go specifically can handle thousands of concurrent tasks using the lightweight Go routines. Okay, so you got an idea about what is a Go routine. So there is let me just cover you one more thing, that what is the difference between concurrency and parallelism. So for that, just imagine a way that how OS threads works. So there, whenever we are pushing a process to the thread should has its availability to process that thread. What do I mean is that whenever I'm pushing a process to the thread, there is one thing, like there is a CPU and the CPU contains finite amounts of cores. So the at the moment of time I am checking that the thread is running, so the probability of thread is running is 100%. What do I mean is that whenever a process is being executed by a thread, so the probability of running that thread is 100%. It is sure that at that moment of time it is always running. That is why OS threads are able to execute a finite amount of tasks only. If I talk about concurrency, concurrency is unlike traditional threads. What it is doing is it is taking a lot of tasks at that same moment of time and it is executing these tasks concurrently. So you have heard about there is a finite number of cores and we have concurrency. So during concurrency, it is not sure that that particular task is running at that particular time. But in parallelism, we have a surety that if a process is executing, that would be executing 100% at that moment of time. So you guys got a little more idea about what is the concurrency and what is parallelism. Although we were not supposed to cover in that video, but I thought that this should be better to cover that in the video. So let me just get straight into how we can write a normal function and how we can write a Go routine. So whenever we are writing a normal function, let me just define a normal function. Hello. So what that function hello is saying, that it is printing a hello statement. and how we can call that function, we have learned that into our previous video. So we just have to call it, and we just have to print that that the function is called for our safety. Function hello called. Let me just run that. So what will happen is that it will first print hello, because hello is a normal function, so the line by line execution will happen, and then it will print the hello function called. Pretty basic, pretty simple. Now how we can declare a function in Go routine, how we can declare a Go routine. So in the prefix of that function only, we have to write a Go keyword. So this is this is the way we can declare a Go routine and run it. So can you guys just guess what is going to happen? Because there is one more thing about Go routine. Let me just run that and I will show you. Okay, so what happened is that the function hello did not got called. Why so? Because what is happening is that Goroutine has been called in the parallel. So what is happening is that, please understand thoroughly that what I am trying to say is that whenever we declare a function into Goroutine, it goes into the concurrent task and the execution keeps running into next line. So what is happening is that it is calling the go hello function in the parallel, and then it call the print statement, and then we all know that if a main function exits, then the execution will end. So basically the Go routine will never get called because the main function got executed. So this is why we would use the wait groups that we are going to cover in the later part of the video. But let me give you an insight that just because the main function, to wait for a particular Go routine to complete, we will use a wait group for that. So expected behavior is that whenever the function is coming to the it is executing in the background, it should be called, but just because the main function got executed for early, that is not been printed. So how we can handle this? Just we can write time.sleep time.second. So you guys got an idea why do I wrote that time.sleep, so that it gets the time to call the function gets executed, function print the print statement, and then you can see that although function hello called is being printed early, because obviously it is printed early, and then I got the time for a second to Go routine to execute, and then the Go routine got executed. Okay, so pretty simple. Let me just go to the channel. This was all for the Go routine, how we can declare a Go routine, how the Go routine runs, what is the theory behind Go routines, what is parallelism and concurrency's difference. So let me just head on towards channels. What are channels? Why do we use channels? So basically channels are the medium for different Go routines to communicate with each other. Now sometimes what is happening, I have just thrown a single Go routine. Sometimes what happens is that we have to throw multiple Go routines, and those Go routines should be run into a synchronous way. That example we are going to take in the end of the video. So what is the happening is that we need to communicate between different Go routines. That is why we are using channels. How we can declare a channel? Let me just clear it out. How we can declare a channel? Just go to the end. So we can make a channel like name ch, and we can use our make keyword. We have to define that it is a channel, and we have to define the data type of that channel, what kind of data we are filling into the channel. Okay, so I have make a channel of integer. How to fill data to the channel? So this is a syntax for that. I have to write the name of the channel, I have to write the arrow syntax, and whatever data I have to fill into the channel, I can write that here. So you can see the arrows direction is to the channel. So please remember that if the arrows direction is to the channel, then we are filling the data to the channel. Okay. and how, and also like we can print that data, we can print that directly like this syntax. Okay, or we can assign a variable to the data of that channel, sorry, and then we can later on print the channel x. Sorry, I did not wrote that. Okay, let me just run it out. So the x, okay, so what happened, can you guys tell me what happens? So basically it is like that we are filling the data to the channel, and if the go routine waits for receiver's data to uh, so basically there are two things in the channels. One is a unbuffered channels and second is a buffered channel. So what is happening is that this is becoming a deadlock because we have defined an unbuffered channel. Unbuffered channel. So the main difference between buffered and unbuffered channel I will go to tell you is like that an unbuffered channel will force the sender and receiver to synchronize. So what it will do is that the sender will wait until the receiver is ready to receive the message. Okay, you are getting my point. So how we can declare an unbuffered channel is the same thing. I have declared an unbuffered channel. A sender will always wait until the receiver is ready to receive the message. Okay, so let me just make an unbuffered channel, and here what we can do is we fill out the value here and we are printing the value here. So it will always cause a deadlock because no go routine is ready to receive the value of that channel. So how to deal with that deadlock? Here we have a concept of what we can say is buffered channel. So how buffered channel is work is that let me just add a new argument to the make. So the third argument in the make is we can decide that how many go routines we need to wait for a particular buffer to be non IO blocking. So what did I just said is that if I write 2, so here I can fill out two values inside the go routine inside the channel. Let me say I fill out 10 here, I can fill out 20 here, and then I can print here I can directly print that channel, and I can also print the second value of the channel. So what is happening is that we are providing the channel information that yeah, I am going to add two values into the channel and you should not block the receiver until I fill out two value. If I fill out third value, it will basically block it, so the go routine thing will happen. So currently what is the execution output is that it first received 10 value to the channel and then it received the 20 value to the channel. Okay, pretty simple. So we also got understanding of why we got deadlock and how to solve that deadlock and why we use a buffered channel and what is an unbuffered channel. Okay, so the next thing we are going to move inside the topics is that weight group. So in the initial video I have already told you why do we need weight group. So let me just explain you again. So when we were printing that hello function and we were calling a go routine, we were calling the hello function to a go routine, and then we were printing a print statement. So things what happening is like that the go routine was executed in parallel, but the main function executed the main functions execution got ended. So basically what were happening is that we were never getting a value of a function that were running into the background. To solve that issue, what we are going to use is we are going to use the wait groups. Wait groups basically waits for a particular go routines to complete, so that the main function we can write the wait group dot wait, so that it knows that we have to wait for a go routine to complete, and even though main function execution got completed, it should wait for a particular go routine. The amount of go routine we have to add in the wait group dot add. So let me just quickly define tell you how we can define a wait group. So we can define a wait group for like the wg sync dot wait group. So we got a wait group from the sync package. We also have mutex from the same package, but mutex I'm not going to cover in the video. For mutex we will make another video. So how we can use the wait group is that we first have to define the how many Goroutines we are going to add in the wait group. So currently I am going to define one Goroutine, so it will wait for one Goroutine to complete in the main function. We can define a function here also. We can use that hello function also. So we can define here function also. What we can going to do is we can print the hello from Goroutine. Goroutine. Okay, that is fine. And here what I am going to do is I want to wait. Okay, there is one problem in the code is that I am not defining where the wait group is getting done. So basically whenever we add a one value to wait group, so it has to be executed for one Goroutine, and inside that Goroutine I have to specify that at the end of the Goroutine that yeah, this function is done. So we have to use wg.done. Why I'm adding to the deferred statement is because that I want that done should always be executed at the end of the function execution. So that is why I wrote that into a deferred. So that is a good practice that you know that thing is going to be called at the end of the execution of the function. So prefer writing those things into a defer function so that you do not miss the done functionality, otherwise it can cause problems. So you guys got an idea like what should be happening is that it will always print hello from Goroutine. Okay, so like even though if I print here something hello, so it will it first print hello, but it should if I do not wrote that wait for wait group, it should be executed and the hello from Goroutine should never have been called. So that is the exact use of wait group, that why the wait group has been used to stops the main function to stop the execution because one Goroutine was running. Okay, so that was pretty basic things about Goroutines, channels, what are buffered and buffered channel, what are wait groups. So we are going to implement those three things into an example. So let me just briefly explain you what example we are taking is we have to print numbers from 1 to 50. So we have to use two Goroutines. One Goroutine will always print odd number and the second Goroutine should always print even number, and the printing it should the both Goroutines should always print in the consecutive way. So let's say that if I am giving a value 1 to the Goroutine 1, then it should signal the Goroutine 2 that yeah, I have printed 1, now you can print 2. Then the 2 will signal to the first Goroutine that yeah, I have printed 2, now you can print 3. So that communication has been done and should be done in between the Goroutines via channels. So that way we will also have to implement the channel to communicate between different Goroutines, because we have to make it a synchronous way. If we do not do that way, that then there is no fixed execution of execution order of any Goroutine I throw. Even though if I declare the Goroutine 1 at the top level and Goroutine 2 at the bottom level, that there is no guarantee that what Goroutine that is going to be executed first. Okay, so let me just head on straight to the example. Let me just clear those things out. So you guys have got the problem statement ready, that what exactly we need to do. Okay, so for that we can define two channel, that is one odd channel that is basically responsible for communication between the odd Goroutine. So let me just make an unbuffered channel only, because we can use struct here. So struct is basically a empty struct that is like used for signaling purposes. So we can use struct only, and we can have an even channel. Here I can also declare that for the struct. Okay, so we have got two channels. One is even channel, one is odd channels. Okay, now we have to declare our wait group because we know that we are going to throw two go routines, so we must wait for the two go routines to complete. Other than that, our main execution should end, and it will just print one two numbers. So that is also not defined. Okay, so I have defined weight group and I will add the value 2 inside the weight group because I know that I am going to trigger two values. Okay, let me create a go function. That function should be our odd function, odd print, and one go routine should print an even number. Okay, inside that Goroutine we just have to do normal things like first of all we have to have done into the first statement. I have told you why, and then we have to just run a loop from I to 0 to like 50 50 I plus equals to 2. You guys got that point, that why I wrote plus equals to 2? It is because that one go routine should print 1 and then should print 3. But when the second go routine signals, then yeah, I have printed 2, now you can print 3. Okay, so it should always print 1 3 5 7, and the second go routine should always print 2 4 6 8, and they should have a synchronization between them. So to have that synchronization, what I will do is I will signal that odd channel. Okay, so we are waiting for that signal from the even channel to print the value. So that is why I have wrote this. And now after printing that, let me just print I will signal the even channel. In the even channel, it should also be listening, waiting for the listening to get the value. So I will signal the even channel that yeah, now you can print. No. So what things is happening inside that is that I am listening for a value to the odd channel. So but for printing 1, I will by default send a value to it so that it starts the execution from 1. Okay, so odd channel will get the value 1. What after that, what it will do is it will print I, that is 1, and it will signal the even channel that yeah, I have printed 1, now you can continue into your loop and you can print the next value. Okay, we will start from, we will not start from 0 here, we will start from 1. And here same thing we are going to do is we in the defer we use waitgroup.done. Okay, we are waiting for the even channel to receive the signal until it prints out any statement. So we will wait inside the loop for I equals to 2, I is less than 250, and I here same again, I plus equals to 2. Okay, we will wait for the even channel to get the signal. We will print the I, and like in the problem statement from what we say that we have to signal odd go routines here. So basically what we are going to do is we are signaling the odd go routines odd channel that now you can print the next value. Pretty basic, pretty simple. And one more thing I need to do inside that even go routine is I have to always after the loop, because that even go routine, it's the go routine that should be executed at the end, because I have to print a number between 1 to 50. 50 is a even number, and in the ending of that loop I have to close those channels. Okay, so I am closing odd and even both channels. Okay, you are getting my point. If I wrote that I have to print values to the 49, then I have written that close logic inside the odd function. So pretty basic, pretty simple. And for the execution to get started, because if I run that, it should never print any value, because the odd channel is always waiting for a signal to the odd channel, and even channel is always waiting for the signal to the even channel. So I do not give any kind of signal to any of that channels. So to get the execution started, what I will do is I will firstly signal the odd channel with my empty struct that yeah, you can go ahead, and the execution should be waiting so that we can use the wait at the end of the function. So everything seems fine to me. Let me just run that code and see if something works or not. Okay. Okay, so why we got fatal error here? It is the reason that we have got a fatal error. You can see that it print 1 to 50, and then it is also trying to print 51. Let me just show you why. Here I have to signal odd channel only when the number is less than 50. Okay, you're getting my point. Why the deadlock come? If I is less than 50, then only I have to signal that yeah, you can signal the odd Goroutine. Okay, now what it print is that it print from 1 to 50. It print in the consecutive order 1 2 3 4 5 6 7 8 9 10 up to 50. So uh, by having our fail case scenarios, we also learn that how we can how what mistakes we did and how to fix that. I intentionally did that mistake so that you guys have a better understanding of any logic that we are applying. So that is like pretty much for that video. I think I know that that video is pretty long. It is already like 25 minutes plus, but still we have covered a really lot of things in the like what we can say the video. So in the next video we are going to cover some more advanced concepts, and then in the later video what so in the next video I should cover mutex. So I will make a mutex. I will cover mutex, and we will have an example for over the mutex, that how mutex work, how what are mutex locks, and why do we need a mutex locks. And then I think it is enough for our playlist to go to our advanced project that is related to service discovery. So we may have multiple videos, or I may cover that service discovery project into one shot only, that I have to decide yet. But yeah, that was pretty much from my side. Like if you guys have any kind of doubts into the playlist, or any kind of discussion we want to have, I am free. You can add your comment. You can contact me on my Instagram, on my YouTube, on my LinkedIn, and like everything is open here. So I will have drop my all the links to the channel to the description only. So you guys go and check out this. Okay, so yeah, that was it from my side, and thank you so much guys for watching the video. I hope that if you are going to have a deep dive knowledge in Go, you may succeed in that, and I will help you guys to succeed in that. I will and possibly share my all the knowledge to you guys. And also please consider subscribing to the channel, because in the previous video we have got views, but 99.3% of that public was not subscribed to the channel, so that demotivates me. So please guys, do motivate me and do subscribe to the channel, do like the video, do share the video to whom you think that it should be a really useful video. So yeah, that is from my side, and I'll wrap it up. Thank you so much guys, have a great day, and take care.